Hey guys, BuildZoid here, and today we're going to be taking a look at another DDR5 overclock with Ryzen 7000. And basically, after the previous video where, I showed how at least some Gigabyte AM5 motherboards now have their high voltage mode for DDR5 fixed, I was just kind of wondering, like, well, what kind of overclocks could you stabilize? And I don't mean like run benchmarks on, I mean stabilize at 1.8 volts on the memory. And the answer is not DDR5-6200 CL24, at least not with this Kingston memory kit, which I guess at this point we might go over the system specs. I have no plan for how, like, the reason I don't write scripts is because I don't know how I'd lay scripts out anyway. So yeah, we're winging it. Here we go. So system specs is a Ryzen 9 7900X that was provided by AMD. Thank you to them for the CPU. Gigabyte provided the X670E Aorus Extreme motherboard. And the reason we're using it is because this is the first motherboard that, like, I happened to grab when, recently for some other testing, and that's when I discovered the high voltage mode works. So it's just kind of, we're going to use it first. I've not honestly really, like, the issue is like, in terms of my experience with the Gigabyte AM5 motherboards that I have access to, is that they all clock memory the same, except for the Tachyon, which is better. So then, like, the overclocking differences just come down to, like, well, maybe some boards don't have the high voltage mode support yet, fixed yet, and so those obviously won't do a very good job, because in terms of the actual, like, physical boards, I think they're all the same. Because, yeah, at least all of the ones I have. Like, I don't have any of the, like, Gigabyte now has a bunch of, like, 6-layer PCB AM5 motherboards. All of the AM5 motherboards I have from Gigabyte are all 8-layer PCBs. Except for the B650E Tachyon, which, if I'm not mistaken, is a 10. Yeah, I'm pretty sure that one's on a 10-layer PCB. But all of the other boards that I have are 8-layer PCBs with daisy chain topology, so it's like the same memory layout, and they clock memory the same, and like in my past experience with them. So really the only difference between like an Extreme and, say, the B650E Master that I have is that one of them may or may not have working high voltage mode support, and the Extreme definitely works. So I wanted to use this because I was mostly interested in what the sticks can do rather than, like, what level of BIOS fixing the motherboard has at this point. But anyway, so that's why I'm using the Aorus Extreme. It's not because it's like I have access to this board, so I used it. It's not because it's like, oh, I think this is the best board to do this with. But yeah, I don't have other. I mean, honestly, the Tachyon would probably be best, but I haven't checked if the high voltage mode on that is fixed yet. Anyway, yeah, but still, thank you to Gigabyte for all of the boards. The memory kit is a Kingston it's a Hynix 16 gigabit A-die based kit. That's the important part. I don't know what, it's like a Fury branded kit. Yeah, Renegade Fury. Anyway, 2x16, single rank, Hynix 16 gigabit A-die. Yeah, I'm not sure how, like, I don't really do a lot of, like, memory. Like, I don't have a large sample size of Hynix A-die memory sticks, so I don't know how much silicon quality variance there is stick to stick. Though I will say, my experience with Hynix memory sticks is that in terms of clocks, they tend to be very similar, and in terms of timings, that's sort of where you see the bigger differences, is like, some kits need significantly less voltage to achieve certain timings than other kits do. So yeah, anyway, so that's the system specs, and also obviously you can see the fans, well, the fan pointed at the RAM, and then we of course have the CPU air cooler, and yeah, a 7900X on a Wraith Prism actually isn't, like, it runs. Like, even Y-Cruncher still manages to run at like 5 gigahertz, and then like Karhu runs at like well over 5 gigahertz because it's a memory stress test, so it doesn't actually load the CPU cores that much. Yeah, so that's actually one of my favorite things about the 7900X is, like, it's a convenient memory testing CPU because you don't need a ton of cooling for it. So yeah, not saying that it's actually like I would personally, like, if I was going for an AM5 system, I'd go with a 7800X 3D. I literally did, but yeah. Anyway, so that's the setup here. And now let's talk a little bit about the actual overclocking. So originally, I really wanted to do like 6200 CL24 at 1.8 volts. on the VDD rail for the memory. So actually, you might be wondering, like, wait, why do you only have like the VDD set to 1.75 volts, and why is like VDDQ at 1.35? There's a very simple reason for that. My experience with DDR5 overclocking, at least on AMD CPUs, because Intel CPUs are super weird. But anyway, on AMD CPUs, which have a sensible memory controller, VDD does not really affect your frequency, like, at all. But what it does do, okay, not literally at all, because technically, as you increase the memory, like, as you increase the data rate, the internal clock of the memory chips actually goes up with it. So I imagine at some point the VDD would actually start affecting the frequency. But the main thing VDD voltage does is you can just use it to force the timings down. So if you have, say, DDR5-6000 working at like 1.3 volts and some loose timings, well, if you just crank the voltage, you can run 6000 at significantly lower primary timings. And the reason I say primary timings is because a lot of the other timings actually get as low as they go at very low voltages. So this is very silly. There's not really a lot of performance gain here for how much extra voltage I'm shoving into the memory sticks. But anyway, I ended up at 1.75 volts instead of 1.8 because the original idea of like, oh, I'll do 6200 CL24 at 1.8, yeah, that didn't work. CL26 at 6200 and 1.8 volts did work. And the reason I tested if that worked is very simple. In some scenarios, if you keep raising the memory voltage, you will actually make the stability worse, not better. It would be super weird for a Hynix A-die kit to actually do that, because as far as I know, Hynix A-die scales to like over 2 volts from what I've heard from other people. I've not actually tested that myself. I've been somewhat careful with my DDR5 memory sticks so far. This is probably the worst thing I've done to them. Yeah, this is definitely the worst thing I've done to any of the DDR5 sticks I have. But yeah, like I've heard from other people that DDR5 scales all the way to like voltages higher than 2 volts. So, you know, it was pretty unlikely that like 1.8 volts was causing instability at like CL24 6200. So I think what the issue was is actually 1.8 volts just isn't enough voltage for 6200 CL24. So what I do plan to do, and I'm not sure, well, I might, I want to do this. Basically, I'm going to check if, like, I think the Asus boards I have might allow even more memory voltage. And if they do, we might do a 6200 CL24 setup. Though I'll hopefully try to keep that video shorter. So, yeah. And also, theoretically, since 6000 CL24 works at 1.75 volts, 7600 CL30 should also work at similar voltages to this. And I might check that. But that I would definitely have to use like the Extreme or the Master or the Tachyon for that, because yeah, my experience with the 2-to-1 mode on the other boards that I have is that it's kind of weak on the other boards that I have for AM5. As in, like, the stability gets really, like this CPU definitely does 7600, and actually on the Tachyon it even does like 8000. And this same CPU and like other motherboards, like, well, one of the boards that I recently tested, 7600 basically doesn't work. And the 7800 is completely out of the question, like blue screens trying to get to the desktop. But anyway, so yeah, I ended up at 1.75 volts. So back to here. So CL24 6200, even at 1.8 volts, doesn't work. So I dropped the speed down to 6000, which I generally wouldn't recommend, especially if you're at like sensible voltages. Like, you're better off running higher speed. In my, like, from all of the testing I've done with Ryzen, more memory clock is more important than like higher Infinity Fabric clock or really anything else, unless you're like massively sacrificing memory timings for it. So like, generally, I would recommend, like, if you can run 6200, you probably want to run 6200 rather than running 6000. But for the sake of this, which was, you know, how low can I get the timings at this insane, like, at very high voltages? Well, CL24 at 6200 doesn't work. So the next best thing is 6000 CL24, because 6200 CL26 needs very, like, only needs like 1.65 volts, right? So there's no point running 1.8 for 6200 CL26 because like that works at significantly lower voltages. So I wanted something that actually requires insane voltage. And I did actually test if like CL24 at 1.7 volts works at 6000. It doesn't. So yeah, 1.75 does, as you can see from the stress tests that have passed here. So yeah, that's how I ended up at these settings, is just like, like basically I smashed the voltage, found out that 6200 CL24 doesn't work, so I lowered the speed and then lowered the voltage. Because the funny thing is, once you have like very low, like when you're trying to push the cast latency really low, the voltage requirements for any given memory speed get absolutely insane. So yeah, like CL26 at 6000 probably only needs like 1.6 volts, maybe even less than that, right? And in order to get like CL24 working, I need like 100 plus millivolts extra, at the very least. Because yeah, like CL26 at 6200 on this memory kit works at like 1.65 volts if I remember correctly. So like the voltage requirements for lowering the cast latency by 2 ticks are just ridiculous, and that's typical of memory. That's not like specific to DDR5. This is also true on like DDR4. You want to go from like CL14 to CL13 and your voltage requirements go through the roof, and from CL13 to CL12 your like the voltage jump is like 250 millivolts in some cases. Actually, there's some memory like some memory well, depends what frequency you're at, but like the voltage requirements ramp up really hard if you're trying to push the timings. If you're, well, it's not even all of the timings, like just cast latency. Because for example, the TRCD timing, yeah, that doesn't scale with voltage. So, or at least it doesn't scale to voltages this high. So yeah, like you can literally buy memory kits with a TRCD 35 XMP. I mean 36 XMP. At like 1.4 volts. And I'm over here at 1.75 and I'm at like 35. Admittedly, I didn't check if 34 is completely unstable, but it probably is. Because yeah, like TRCD really, like it scales a little bit. Like you'll see an improvement in TRCD going from like 1.1 volts to like 1.6 maybe? But any more than that, and it's just like maybe if you went all the way to 2 volts, it would do another 1 tick less at some point. But yeah, I don't have access to 2 volts on this board. So anyway, so that's how I ended up at this like 6000 CL24 setup, is just like, yeah, like the other. I mean, I guess somebody might be like, well, why didn't you try CL22? And I actually don't even know if the Ryzen memory controller supports a cast latency that low. It probably... No, I'm pretty sure it does. But the thing is, at that point, we'd probably be at like DDR5-5200 or something, and that's just dumb. Like, these settings right here, as they are, I'm honestly kind of tempted to try, like, full daily them. Because this isn't really that hard to stabilize. It doesn't, like... well, yeah, it's not, like, I'm not super concerned about this actually harming the CPU, because... as far as I understand, the VDD voltage with DDR5 is completely internal to the actual DDR5 memory chips themselves, so like the CPU shouldn't be getting exposed to this whatsoever. So really the only thing that, as far as I know, should be at risk in this setup is the memory sticks. And memory sticks are significantly cheaper than CPUs, and I do have spare DDR5 sticks. So like, doing something silly like, dailying DDR5 at like 1.75 volts for like a year or longer, or like just to see like will it fail? Because the thing is, like, there's no like the DRAM manufacturers, they don't have like, hey, our memory will work for like 10 years at 2 volts. Like, nobody does that. The DDR5 spec only goes up to 1.43 volts, and that's like the memory chips won't like, and that's not even like they're required to work at that, right? Like, DDR5 is designed to work at 1.1 volts. How it behaves at any other voltages than, like, well, basically how it behaves above 1.43 volts is undefined, and as far as I know, relatively untested, other than, like, people on forums and stuff. So, Yeah, but I did think like because this is very stable. And yeah, the only thing that's really like at least as far as I know, the only thing that's really in any danger is the memory sticks themselves. And like I said, I'm fortunate enough to have backup memory sticks. So, doing something silly like dailying a 6000 CL24 overclock sounds a little bit appealing. Um, Even though from a performance perspective, this really like you could run much more sensible voltages and run very similar timings to what I have here. Like TRP actually doesn't go below 28. Like I tried 26. Y-Cruncher got very upset about it. Um, so yeah, and like TRP 28 works even at like I think 1.45 or 1. Maybe even 1.4. Like I haven't really 1.4 is probably too low. But I think at like 1.6 it definitely works. Um, and I'd feel like 1.6 I would actually be relatively confident that like Hynix memory sticks can take that long term, especially if you have like proper cooling for the memory sticks. Like, pointing a fan at them because like RAM doesn't actually produce a lot of heat. It's just heat like passive cooling is not really very effective. So, like basically any amount of forced airflow goes a long way for making your memory sticks run very like at low temperatures. Also, 16C is a temperature sensor error. There's like a lot of DDR5 memory sticks where the temperature sensors on them are like super glitchy. Um, so yeah, also the 47.8 I'm pretty sure is the same thing because like yeah, I like these memory sticks will basically like the max temperature will I guess there might be a glitch where like glitches out by a fixed amount because the other temperature that I've always seen is like 63.8. I think 60. Yeah, I'm pretty sure it's 63.8. Is the other like temperature that these memory sticks will have a tendency to report. But I guess it might be tied. Like I guess if they go over 40, then they might report 63.8, and if they're like around 30-ish, then they report 47.8 or something like that. I've not really looked into it too much because basically my view on memory temperatures is like if it's passing stress tests, it's good enough. Also, since I run open air test benches, I don't have to worry about how the GPU affects the memory thermals. But that is an actual concern if you were running a case, is like if you have a 4090 and the air temperature goes up by a significant amount, that will actually affect like the stability of timings like TRCD, TCL, TREFI is like especially sensitive to high operating temperatures. Though like 65,000 TREFI in my experience works all the way up to even like 60 degrees Celsius. So that wouldn't really be a concern in this setup. I'd be more worried about like the cast latency requiring a low temperature because that is a thing. That you can run lower timings if the memory sticks are just somewhat cooler. Anyway, so in terms of stress testing, yeah, we've got Y-Cruncher, VST, and VT3 for over an hour, right, around 4,400 seconds. And then for the other memory test, I just ran Karhu. Didn't really feel like setting up TestMem 5 because it's a bit jank. So like this wasn't really meant to be like a super because like I wouldn't like on one hand looking at these settings and like I wouldn't personally I'm kind of tempted to literally just take these sticks, update the BIOS on my daily system, and like put these sticks into my daily system and basically try to daily these settings at this point. I would actually have to run a stress test on these because these are pushing it, I think, with the stability. I'm not 100% certain that I'd obviously still run a stress test, but I am kind of tempted to just like try run these settings on my daily system, but I wouldn't actually recommend people do this. So I haven't gone through like the full battery of memory stress tests instead of just doing the lazy thing of just like start Karhu and like do other things for 24 hours. That doesn't require instead of like setting up testmem 5 wouldn't have taken that long. I am very lazy. Anyway, but yeah, so it like past 24 hours of Karhu, it runs Y-Cruncher. This is very stable. I mean, it's not like, it's not exhaustively stress tested. Because again, like if I wanted to test this to like exhaustion, I'd also run like HCI and test Mem5 and more Y Cruncher, but like this isn't really like I don't really consider this a serious overclock, even though I have stress tested it for over 24 hours. Um, because like this is just not very realistic to do for most people. Um, but anyway, man, I wanted to go into the BIOS. Actually, we will go into the BIOS. So, um, yeah, because I feel like looking at the settings in the BIOS is a lot easier to see what's going on than like this. So let's restart now, which now means I've committed to this take of the video. Because I don't particularly, like, I do have a screenshot, but I don't really want to talk over screenshots, because, like, yeah, it's just, I feel like if you want to prove something actually works, you need to be able to, like, you know, have it running. um, that's also why for, like, some of the memory overclock videos in the past, like, I actually stop the stress test in the video if, like, if it's the first take of the video, then, like, yeah, if the first take is good, then you'll actually get to, like, see me stop the stress test for the video. Though I didn't do this for this one, because the Wraith Prism, like, sure, the 17900X doesn't actually run that hot running Karhu, but it's still ramping the fan speed up and down, and it's annoying. So I did turn it off after 20, like, I did stop memtest manual, Karhu after 24 hours manually, because I didn't feel like listening to the Wraith Prism ramp up and down as the test cycled. But anyway, so here we are in the BIOS. The CPU is completely stock, because this is a memory overclock, not a CPU overclock. Yeah, so 60 on the memory multiplier, Infinity Fabric at 2133. I am not I am like actually this from a stability perspective. The sketchiest thing about these settings here is that 2133 Infinity Fabric. Now, apparently, based on other people's testing, the new BIOSes also have like a big improvement. The latest BIOSes have like a big improvement for Infinity Fabric stability. But I've seen Ryzen CPUs have like Infinity Fabric instability that shows up like once every several minutes. So that's the kind of thing that you can't even stress test for it, because your stress test isn't going to pick up a performance anomaly that shows up for like once every couple minutes. That's just like not possible to test for. And so I haven't like exhaustively stress tested the Infinity Fabric on this CPU. So honestly, like basically what I'm trying to say is this 2133 here is a bit untested. It did pass Y Cruncher, but that doesn't actually mean like with the Infinity Fabric on 7000 series, it doesn't tend to crash until it's like really unstable in my experience. So yeah, just because Y Cruncher and Karhu pass does not automatically mean that I trust this 2133 Infinity Fabric. So that's like work in progress there. But anyway, UCLK equals MCLK, because yeah, we're at 6,000. Now the nice arguably nice thing about these settings is that because we're at such a low memory speed, we can run a relatively low SoC voltage. Now, there are some CPUs that even at 6,000 might need like 1.2 volts of SoC, but generally at 6,000, you really shouldn't need much SoC voltage whatsoever. So 1.15 volts, and actually low SoC voltage helps with Infinity Fabric stability. So that's like a sort of annoying trade-off, is like if you want to run high memory speeds in UCLK equals MCLK, you need a lot of SoC voltage. That's just a requirement. You don't have a choice about that. Like you want to run 6200, 6400, if you're very lucky, maybe like even 6600. You're going to need a lot of SoC voltage to do that. And high SoC voltages directly harm Infinity Fabric stability. So, yeah. Whereas if you're at low memory speeds, or if you're in 2-to-1 mode, you can use very low SoC voltages, and that allows you to potentially run slightly higher Infinity Fabric. Though, in my testing, generally, like 6200 with, say, like if we were comparing 6000 2133 versus like 6200 2100, 6200 2100 is faster in my, like, from all the testing that I did, like a long time ago. So I don't know. I might have to redo that testing, but I don't think that changed because I don't see a like logical reason for that to change. Though at the same time, the performance differences are so minor that, like, you know, I think if you're like paranoid about the SoC voltage thing, you're like you could go with the like low memory speed, higher Infinity Fabric option rather than high memory speed, potentially slightly lower Infinity Fabric. Even though I'm pretty sure high memory speed, low Infinity Fabric is always going to be better for performance. In 1-to-1 mode specifically. In 2-to-1 mode, things are very different. Anyway, VDDIO MEM, we're at 1.35 volts on that. So the VDDIO MEM, this is the voltage that's actually fed to the memory controller that the memory controller uses to talk to the memory sticks. Because, well, just for comparison, like in the DDR4 days, the memory controller and the memory sticks would talk to each other using the VDDR voltage. So, yeah, VDDIO MEM is basically the replacement for that, and I have it set to the same thing as VDDQ because, and this isn't a like hard rule, but because these are both signaling voltages, so like VDDQ is what the memory, as far as I know, is what the memory uses to talk to the CPU, and this is what the CPU uses to talk to the memory. I tend to just default to having them the same unless I'm testing settings where they absolutely have to be different. And at DDR5-6000, they can be the same because, yeah, maybe one of them could be slightly lower, maybe they could both be lower. I don't really care because 1.35 volts is perfectly safe for both of them. So I'm not concerned about that in the slightest. And then we, of course, have the sky-high VDD voltage, but as I mentioned earlier, as far as I know, VDD literally only goes to the memory chip. The CPU never sees it, and so I'm really not concerned about this harming the actual CPU itself. It might harm the memory sticks, but there's no there's no hard evidence for that. I certainly don't have any. Yeah. So, like, if you're looking at the settings I'm showing here and thinking like, oh, I want to do this too, I hope you like basically. I would not recommend copying these settings unless you feel okay potentially having to replace a memory kit sometime in the future when your insane memory voltage like breaks the memory chips. That's the main concern with this. Anyway, VPP's on auto because, yeah, it like. Funnily enough, according to the DDR5 spec, VPP should always be higher than VDD by a significant amount. But interestingly enough, even with the VDD, when I was testing the 1.8 volts, yeah, there was a really, like, it worked, which was kind of surprising because, yeah, the DDR5 spec makes a kind of a big deal about how VPP always has to be higher than VDD. But apparently not. Like, the memory still works, even if your VPP voltage is below VDD, which is kind of interesting. But anyway, so yeah, that's on auto because, like, there's no reason to increase it in this setup here. Advanced voltage settings, right, we're at like 6000, so I didn't really have to do anything. Oh, I think this got reset because I'm pretty sure this was at 1900 at some point in time. Wait, maybe it's still set over here? No, it isn't. Interesting. Anyway, for CPU VRM settings, I haven't done anything because, yeah, like, the funny thing is, like, because we're running, like, low memory clock, like, the SoC voltage and the VDDG voltages and, like, VDDP, these all work very well on auto. Now, VDDP specifically, the auto is not stock, okay? It's whatever your motherboard manufacturer decides is optimal for your memory speed. But in my experience, that, like, I haven't seen a motherboard like set VDDP like ridiculously high yet, so I'm not too concerned about just leaving that on auto. And VDD misc actually just like doesn't do anything. So yeah, you can just like like stock it's 1.1 volts. It just powers the VDDG voltage regulators. You don't have to worry about that. I don't worry about that. Well, the only scenario where you'd have to increase it is if for some reason you need a really high VDDG, which is like not a thing in my experience. So by really high, I mean like more than like 1,050 millivolts on either of the two VDDG voltages. Which in my experience, if you set one of them really like off the top of my head, I want to say the IOD voltage. If you set that one really high, it actually causes instability. So there's like really no reason to like to set those higher. In some cases, on some motherboards, if they have like wacky auto rules, you might benefit from actually setting them lower to something between like, well, I usually would set them to something around 900 millivolts. And I think Gigabyte defaults to like, I think Gigabyte defaults to 1,000 on both of them, which is a bit high, but well, anyway, let's take a closer look at the timing. So first of all, yeah, CL24 sounds really low and impressive until you consider like it's DDR5. It actually doesn't make that much of a difference, but hey, that's the one timing that actually like really benefited from all of the extra memory voltage because everything else barely changes. TRCD at 35. If you had, I'm pretty sure that there are Hynix 8i sticks out there that could do TRCD 34 with this voltage. But yeah, I don't think these do. So anyway, TRP28 is actually the limit for these memory sticks at 1.75 volts. I tried 26, it doesn't work. TRAS at 30 because that's the register limit for AMD CPUs. Yeah, Gigabyte motherboards won't let you set it lower. There are other motherboards that will let you set the TRAS lower, but I am not entirely certain what that actually translates to. Because depending on how the timings are actually being encoded for the memory controller, it literally like I don't know again how exactly the memory controller converts from whatever you punch into the BIOS into what like it actually does physically. But based on some of the things I've seen with like other memory timing related stuff, and this is specific, like in this case it was GDDR memory timings, I am pretty sure that like the CPU actually just can't like define values that are outside of the register limits. So if you set something below the register limit, it just like there isn't like a number to represent the number you punched into the BIOS. So it just goes to the register limit, which should be 30. Now, I'm not sure how like timing readouts actually, because I know that if you have like an Asus motherboard or an ASRock motherboard and you set TRAS like insanely low, it still reads out correctly in software, but I don't know if that actually means the CPU is doing a TRAS that low. Because yeah, I don't design memory controllers. And even if I did design memory controllers, I don't design the one at AMD. So anyway, TRC's at 58 because I do just stick to the rule of TRC is equal to TRAS plus TRP. Though with DDR5, the TRC behavior has changed somewhat. And TRAS behavior for that matter as well. TRP is... actually, like, the relationship between these three timings seems to have changed somewhat, as in, like, on AM4, you could intentionally, like, set your TRAS impossibly low, and as long as your TRC was a sensible value, everything would keep working. With AM5, that no longer works. I don't know why that doesn't work anymore, because, like, as far as I know, TRC really should just be TRAS plus TRP. But yeah, I still stick to that rule of just, like, it makes life easier if I just set it to TRP plus TRAS. If you feel like spending time spending more time investigating TRC behavior, you're free to go do that. Worst case scenario, you're going to have to clear the CMOS, which on some other boards can be very fiddly. Anyway, TWR is at 48 because that is the register limit, so Gigabyte doesn't let you go below that. Again, like other motherboard manufacturers do, but I'm not sure that it actually does anything. TREFI is at 65,000, which again is the register limit. Also, you can set TREFI sky high even on like auto voltages. TRFC is at 500. This could be lower, but the thing is, when your TRFC is so the way TREFI and TRFC work is that every 65,535 clock cycles, the memory controller issues a refresh command, and then for 500 cycles, the memory basically does refresh things. Which, if you do the math, 500 divided by 65,000 is like less than 1%, which basically tells us, yeah, the memory spends less than 1% of the available clock cycles refreshing. So if I go and reduce that, like, less than 1% by another 10%, we'll go from, like, like, let's say it was 1%. So if it was, like, 50,000 TREFI, if it was like 50,000 TREFI, and I drop this to 450, which might actually work. Though I think these memory sticks specifically seem to have like a weirdly weak TRFC. Because I was having some really major stability issues with these at like 7600. And I think it was actually TRFC related. Not TREFI related, TRFC related, which is like super weird. But anyway, let's say you went from 500 at 50,000 to 450 at 50,000. Well, what this would actually do for your available clock cycles is it would increase them by 0.1% because your refresh, which previously took 1% of your available clock cycles, now takes 0.9% of your available clock cycles, which good luck measuring that. Actually, there are some benchmarks that are sensitive enough to pick up on that kind of thing, but if your OS isn't like dialed, as in like, yeah, if your OS isn't like very well set up, random variance is gonna have more impact on the score than what your TRFC is if you're like changing it by 50 clock cycles when your refresh interval is maxed out. Speaking of maxed out, we're going to set that back to maxed out. Anyway, TRFC2 and TRFC same bank aren't currently used by the AMD memory controller, which is kind of sad because they're technically a much more like efficient way of doing refreshes. That was like, is supposed to be one of the main benefits of DDR5, and AMD memory controllers just like don't do that. But I don't think, like, once you set your refresh interval to 65,000, I don't think it really matters very much which of the refresh schemes are being used. RTP at 12, I think I tried 8, and that got really upset with me. So yeah, and I don't think I tested 10, so I just ended up sticking to 12. TRRDL and TRRDS are at 4. These don't go any lower. I'm not sure if there's any motherboards that let you set these lower, but they definitely don't go any lower on gigabyte boards, right? If I hit the minus key on that, it just goes straight to 4. T falls at 20 because, yeah, like, as far as I know, the register limit is 20, and so gigabyte motherboards don't let you go below 20. I know other motherboard manufacturers do let you go below 20, but I'm not sure that it'll actually have any impact on performance, because again, like, if the CPU doesn't accept values of less than 20, then, like, anything that's less than 20 just becomes 20 at that point. Anyway, WTRL is 16. WTRS is at 4. These are actually just from the, like, lazy Hynix DDR5 timings. They might actually go lower with this much voltage, but I didn't really feel like having to deal with a bunch of, like, the goal for me was to, like, I was mainly interested in seeing what kind of cast latency would work with insane voltages. I wasn't really that interested in all the other timings. And I do acknowledge that I'm, like, one of the people who, like, points out that, cast latency actually really doesn't have much performance impact, which is true, but it does scale with voltage. So that's why I was more interested with cast latency than, like, trying to minimize all of the other timings. TRRD SCL is at 4. SC is at 1 because it doesn't go below 1. I'm kind of like I am kind of wondering if like 3 would work, because I think read to read might scale slightly with voltage. Yeah, that might scale slightly with voltage. So maybe it'll do 2 now, but I might test that after this video. Well, actually, we could see if it posts right now, but, well, we'll do that after we get through all the settings. So right to right is at 2. I'm pretty sure it actually even works at 1. But yeah, like the performance difference is just going to be non-existent. And the same is actually kind of true for TRD SCL. Like setting it to 2, even if it did work, it's not going to change the performance very much. Because the memory controller like is literally, and I'm not sure how good the AMD memory controller is at doing this, but the memory controller is really supposed to be using the SC timing instead of the SCL timing. This is worst case scenario memory access. This is best case scenario. And with DDR5, the best case scenario should be the majority of memory accesses. Just because of how like DDR5 is physically designed. So anyway, TWRD, I have it at 4 and 6, and TRDWR at 16. I didn't check if these go any lower because I didn't want to spend that much time on this. Anyway, and then all of this down here, we're just on auto because Gigabyte motherboards seem to do a perfectly good job of like setting these up on their own. Like I've tried messing with these in the past, and I never, and like ultimately the only like settings I ended up with were the same settings that the motherboard was using anyway. So, may as well leave it on auto. Oh yeah, I didn't disable any of these over here because like technically disabling gear down mode does give you more performance, slightly more performance, and also like this is like this is technically the like most optimal setup for these settings from a performance perspective, but well, if you so if you leave memory context restore enabled and you disable power down mode, things are going to be very unstable. Not after the first boot, but after later reboots, you're going to have massive issues. And I think also like sleep is going to break and stuff, but I don't use sleep mode, so I don't know about any sleep issues. But I do know that like if you have memory context restore enabled, power down disabled, then your like stability after multiple reboots is just going to be non-existent, because it causes some kind of like memory context restore bug. Because really, as far as I know, power down mode shouldn't really be affecting the memory reinitialization, but yeah. And then gear down mode, this can disabling gear down mode gives you more performance, but it might like tank your stability. So yeah. And like off the top of my head, I want to say it doesn't make that much of a difference to performance. So I don't usually bother with setting it because in many scenarios it can end up being significantly more effort than it's worth. Anyway, like if I was like running benchmarks for like HardwareBot or something, then yeah, I'd be trying my best to get gear down mode disabled. But for like 24/7 stability, I'll just leave it on because yeah, unless it like I guess I could have checked if it in this case I didn't even check if it would work with it disabled, but yeah, if it doesn't just work on its own, then I wouldn't really put effort into trying to make it work anyway. And that's it. I think the only other thing I might have done was yeah, this right here. So this basically makes sure that when I was tuning the timings, it didn't take 4 minutes to post. Is what this does. So Gigabyte motherboards actually enable that by default if you use your XMP profile, but I didn't. I think I forgot to turn on the XMP profile. It doesn't make a difference because ultimately I'm setting all of the timings manually, so XMP Expo don't actually affect that, but they do affect potentially some like auto voltage settings elsewhere in the box. Oh, that's probably why the VDDGs are on auto. Yeah, that's probably why. Is because I forgot to turn on XMP. Well, anyway, yeah. So that's the settings that I went with here. Honestly, the funny thing is, if you just went to a sensible voltage, a very sensible voltage. Okay, not that idiot. 1.43. So if we went with a very sensible voltage like that, right? Basically, the only adjustments that these timings would need would be and that's it. Like, I would fully expect this to still work. So yeah, that's like the main counter argument against running like insanely high VDD is like it doesn't actually do very much. Like, yeah, your cast latency gets really, really low, but cast latency doesn't have like it really doesn't affect performance as much as people like to think it does. Um, so yeah, it's really like for me this was very like that's why I consider this whole setup a really like silly thing to do because it's like from a practical performance perspective it's like yeah it's not actually significantly faster than if you just used like sensible timings at 1.43 volts because sensible timings at 1.43 look very similar to like not sensible timings at 1.75. But on that note I do kind of wonder about the TRP thing. Because I don't remember testing that. Will it actually just not post? Because I definitely tried RTP at 8 at one point, but it didn't want to boot. And I can't remember why it didn't want to boot. So now that I'm done with this, we may as well break the settings. Though I am going to bump the voltage back up to 1.75. Go. It might have, like, the thing is I was probably setting two timings at the same time, so it's possible that it was something else causing it to not post, and the RTP was a misdiagnosis on my part. Oh, no, it wasn't. I was right. It doesn't work at 8. Cool. So, yeah, that doesn't work. Anyway, that's it for this video. Yeah, if you're, like, if you don't care about the, like... Yeah, if you're not too concerned about the longevity of your memory sticks, shoving 1.75 volts into them is a way to be able to lower the cast latency, like, a bit. Yeah, you can go from, like if you have 6000 CL30 working at, like, 1.43 volts, well, now or 1.4-ish, you can now do 6000 CL24 at 1.75. For the negligible performance gains that's going to provide. Yeah, but it'll look really cool if you like, or like it'll sound really cool when you post about it on forums or whatever. Anyway, yeah, that's it for the video. I do think I will briefly try 7600 CL30 because theoretically that should work. And actually, you know what? I'll show you why theoretically that should work. So let me just pull up a calculator. Oh no. Oh no, I've screwed up the layout. Okay, we're gonna put the system... Oh, the system specs are locked into place. Well, that was very clever. Anyway, but, so... CL24 at DDR5-6000 is equivalent to CL30.4 at 7600. So, with 1.8 volts, I think CL30 would work at 7600. Which really, like... That sounds a lot less impressive than CL24, at least to me. Even though they are literally the same thing. Right? Like, from a nanoseconds perspective, CL30... Actually, CL30 at 7600 is slightly less cast latency than CL24 at 6000. But, like, for, like, at least to me... It's like perception. The perception is like CL24 is like more lower. Like the CL24 at 6000 is like more. Well, I guess it's more weird. The thing is, like at 7600, you're already in like the 30s. You'll be at like 36 or 38 or something, maybe 34. And so, like, you know, going down to like 30 doesn't really sound that impressive compared to the other options that you have at 7600. But going below 30, and then significantly below 30 at 6000, like, at least to me, sounds cooler, even though like it is literally the same thing. Um, but anyway, so I might briefly try it. Like I'll probably just check if like Y Cruncher works for like I don't know 30. I'll ditch VST and I'll check if like VT3 runs for like an hour and then like an hour of Karhu and see if that works. And I don't know, I might post a screenshot or something of that. I don't think that deserves an entire extra video because like the 2-to-1 mode is, especially at 7600, I don't think it's worth it. In my testing, it's just like, sometimes it does, like, sometimes it wins some benchmarks, sometimes it loses some benchmarks. It's like, it's a wash. Now, if you're at like 7800 or 8000, especially 8000 is actually justifiable, but getting 8000 to work is like very is very difficult. And actually, I'd say requires a few very specific motherboards rather than like, or maybe just binning enough CPUs. Because that's always an option. If you just bin enough CPUs, you can get even mediocre motherboards to do impressive things. But anyway, this video is now way longer than it really needs to be because, yeah, structuralist rambling. Here we go. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, which is how I was able to buy the memory sticks that I used here. And also a Teespring store where there's like shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. Links to all of that in the description. Much appreciated if you'd check them out. And that's it. So thanks for watching and goodbye.